All right, in problem number 1, we have these 3 circles, circle A, circle B, and circle C. And when you see circles labeled like this, when it says circle B or circle A or circle C, you can assume that the point, for example here, for circle B, the point B is the center of circle B, okay? And circle A, you can assume that A is the center of circle A, okay? So, so we're given circle A, circle B, and circle C, and we're told that circle B is tangent to circle A at x. Okay, so you need to know what this word means, tangent. So tangent just means that it touches at exactly one point, okay, and that point they're telling you is x. Okay, so it's tangent, so it's just touching at one point. Alright, and we're also told that circle C is tangent to circle A at y. Okay, so again, this circle C is just touching at one point, and that point is y. And then we're also told that circles B and C are tangent to each other. Okay, it doesn't have the point labeled, but that just means that they're touching right just at one point right here. Okay. And then we're given the lengths of some line segments here. So AB is 6. Let me actually write that on here. Let me change colors here. So AB is 6. So I'm going to write 6 right here, okay, from A to B. We're given that AC is 5. So let me write that on here. 5. And we're given that B to C is 9. Alright, so I'll write 9, and we'll put it right on here. Okay? So, I think that's all the information we're given, and we're asked to find what AX is. So this line segment A to X, we're asked to find that. Alright, so let's work with what we know here. I'm going to actually define some variables. I'm going to call R sub B the radius of circle B, okay? And R sub C is the radius of circle C, okay? I'm just going to define those as variables because I can see here that if I knew the radius of B, then I could just add 6 to it and I would get the length of AX, which is what I'm looking for, okay? So I'm going to define those as variables, and it's often a good idea to define your variables so that they're meaningful, okay? So that I'm using R for radius and then the subscript B or C to designate which circle I'm talking about, okay? So it's a good idea to define your variables so they're meaningful. All right, so let's figure out what do we know. Well, one thing I'm seeing here is we know this length here from B to C. That's 9, and so you can see that this segment is coming from the center of B and is passing through this tangent point and going to point B. Okay, so that's telling us that the radius of B plus the radius of C is equal to 9. Okay, so we can work with that. We also know that the radius of A has to be the same all the way around. I mean, that's just the definition of a circle. A circle is just defined as the set of all points that are the same distance from a center point. Okay, so we know that this length AX has to be equal to AY. So I'm going to write that down as well. AX is equal to AY. Okay? And we could also write AX as just 6 plus RB. So I can just rewrite that as 6 plus RB, and that's equal to 5 plus RC. Okay? You see how I got that? It's just because the radius of A has to be the same no matter where you draw it. So that gives us another equation. I can rearrange this, and I can actually put all the, let me put all the variables on one side. So I'm going to subtract RC from both sides to preserve the equality, because if I do the same thing to both sides, then it's still equal, right? So if I subtract RC from both sides, and let's subtract 6 from both sides. I kind of want it to look like this equation, right? I've got RB plus RC is 9. So let's subtract 6 and get all the constant terms on the right and the variables on the left, and then I'll end up with RB minus RC is equal to 5 minus 6, which is a negative 1. Alright? And now you can see I have two equations and two unknowns, and that should be pretty easy to solve. That's just basic algebra. So let me rewrite this equation over here. RB minus RC is equal to a negative 1. Alright, and I can see right now, I could solve for one of the variables and do a substitution, but I can see right here that I have a plus RC and I have a minus RC. And if I add these two equations together, I'll end up with 2 RB, right? And then when I add RC and a negative RC, that's just 0. And then when I add 9 and a negative 1, I just get 8. So that tells me that RB is equal to 4. Hey, now we got it. Because we know we want to find out AX, all right? So AX is just 6 plus RB. Oops, I don't want to write 6RB. I'm going to write 6 plus RB. 6 plus RB, right? And now we know RB is 4, so 6 plus 4 is equal to 10. Alright? We're not given any units on this, we're just given 6, 5, and 9, so we don't really have to worry about units in this case. But so the length of AX is 10 units. Alright? There you go.